Generative AI is everywhere. In this video, I will use ChatGPT to extract data from unstructured documents. As an example, I will extract the currency of a company's financial reports. While ChatGPT is a fascinating technology with countless use cases, it is unfit for extraction tasks. They are highly inefficient comparing the achieved quality and necessary computational resources. You will find ChatGPT to be imprecise and inconsistent. Finally, extraction results of generative AI models are difficult to integrate with humans or downstream machines. As I do the preparations for this task, I kindly invite you to witness the speed, versatility, and reduced training data requirements that the Cognize AI platform delivers to its users. Validated by McKinsey's 2022 State of AI report, these factors are integral to a successful implementation of artificial intelligence. First, we create a new collection named Currency. We can use doctr OCR. It is specifically trained with financial data by Cognize, and as a result, outperforms generic models. Let's use ChatGPT to find reports. Activate the browsing mode to grant it access to the internet. Then we can prompt it to find the financial statements of Melrose Industries plc. In its typical convincing manner, ChatGPT returns the URL. But unfortunately, it is wrong. However, at least the domain is correct, and we can find the reports with a few clicks. We can bulk upload the documents now. The Cognize AI platform will correct the page rotation and skewness automatically. Additionally, every document will be indexed with Cognize finance-specific language model, allowing for precise semantic search. Next, let's create an insight. Recall that insights are representing the knowledge you would like to gain from the document. Our insight has only one extraction field with the data type text box. Also, mark it as repeatable, since the currency is likely mentioned several times in the document. We can now open one of the PDF documents and attach the newly created insight to it. As you can see, the company is reporting in pound sterling. To test the OCR result, we can label a few instances of the currency symbol. Ideally, the AI model will later return the currency and label an instance of the symbol to demonstrate the source of the information. We now define the interface to the AI model, create a version, and start a development environment. The Cognize AI platform allows for fast AI development through an extensive SDK that forms a seamless bridge between AI models and the experts working with the documents. The ability to instantaneously set up any use case through the Cognize AI platform is an essential aspect for a successful implementation of artificial intelligence. Some of our clients have reduced the processing time of their documents from 45 minutes to less than 15 minutes in a matter of weeks. We can now look at the first problem of large language models. They just need too much resources. OpenAI has not officially revealed the number of parameters used in training ChatGPT-4. However, estimates suggest it could be around 100 trillion parameters. Even the 175 billion parameters of GPT-3 reach hardware limits. Beyond the extensively discussed severe carbon dioxide emissions, large language models also bring about hardware-related restrictions that notably impact their performance in extraction tasks. Take a look. The code at the top of this section uses the OpenAI API to access ChatGPT 3.5. The Cognize SDK allows for seamless access to any previously gained knowledge, including the doctr OCR model results. We can simply concatenate the OCR of each box to a large string. Then we can prompt ChatGPT with the question, "What is the currency used in the financial report?" Let's print the answer for a quick look, but with just one command. We are also sending it back to the Cognize AI platform, which will show the result in the graphical user interface, allowing for expert validation and adjustment. Let's see what the result is. Remember, we are expecting the pound sterling as an answer. Unfortunately, we got an error message. The OpenAI API does not allow more than 4,097 tokens, while we have sent over 200,000. This limitation is due to computational efficiency, as the complexity of transformers is roughly quadratic with respect to the sequence length. In this specific case, we can cope with the limitation by sending fewer pages, as the reporting currency is mentioned on almost all pages, starting at the second page. We are finally expecting the pound sterling as the answer. Unfortunately, we are getting the wrong answer. The financial report does not specify a currency. The pound sterling is mentioned several times on most pages sent to the model. Large language models have reached hardware limits. As a result, they are limiting the token length. Tokens essentially form the input into the model. They can range in size from a single character to a complete word. For instance, this particular text comprises 33 words and would yield 40 tokens if fed into ChatGPT. The context window, or the portion of the text the model can actively consider, is defined by this maximum token count. For a chat application, it starts from your current prompt and goes back in history until the maximum token count is exceeded. Everything prior to that never happened for ChatGPT. Though this might pose slight inconveniences in a conversational context, it is not a critical constraint. However, in tasks like document extraction, a small context window naturally yields to imprecise outcomes, as witnessed in the example. More often than not, the reader would need to understand a larger text corpus to answer a question. I will present a workaround to the resource restrictions, but we immediately run into the next problem. Large language models are just inconsistent. Depending on how you ask the question, it might answer differently. Even if you ask the exact same question several times, it might still answer differently. This well-known phenomenon is the reason why prompt engineering is now one of the highest-paid jobs. For extraction tasks, this is a serious problem. Take a look. Another approach to getting an answer to a question is an embedding-based search. An embedding is just a list of numbers that represent a word so that it captures the meaning of the word relative to others. In a well-trained model, the embeddings for words like king and queen would be closer to each other than, say, king and apple. Embeddings work especially well with questions, as those often don't lexically overlap with their answers. The code above embeds the whole PDF document and stores the vectors in a temporary database. After receiving the question, it generates an embedding for the query. A retriever fetches the relevant text chunks using the embeddings, while a synthesizer combines the information into a final response. I am using the Ada model of OpenAI. It is capable of simple tasks and is the fastest model at the lowest cost in the GPT-3 series. Ada is not a chat model but has been trained to embed language. We are now ready to test the answer again. It took over 3 minutes, but we finally got the correct answer. The currency used in the financial report is sterling. Besides the immense waiting time for such a trivial task, there is another huge problem. Let's try this prompt. Does the company report in US dollar? We expect no as answer since the company only reports in pound sterling. After thinking over 3 minutes, the large language model answers, yes, the company reports in US dollar. As we know, this is wrong. It highlights a problematic weakness through inconsistent results depending on the prompt. As you have witnessed, large language models are inconsistent. While the reasons behind this are still heavily discussed by scientists, it is clear that the overly large size is detrimental. At Cognize, we have trained a language model just for the financial industry. It is significantly smaller with just 7 billion parameters compared to the 175 billion of GPT-3. However, it outperforms GPT-3 on tasks relating to the financial industry in speed, as well as accuracy. Note that for this specific task, you do not even need a language model. As contrast, let's look at how easy it is to work with a dedicated extraction model. We just need 2 lines of code. It delivers a correct result, but it will continuously learn on your data, if necessary. It is very fast. And finally, your data stays private as these models run on your hardware or your cloud subscription. As expected, the correct answer is British pound sterling. The implementation of the AI model into production can be accomplished effortlessly with a single click using the Cognize AI platform. Extraction models, exemplified by the currency model previously demonstrated, facilitate straightforward extraction of precise values without engaging in language generation, thus enabling seamless integration into downstream applications, as the result does not need to be interpreted. Moreover, a pivotal component of automation lies in the meaningful integration of human expertise with AI capabilities. The majority of extraction models possess the capability to precisely pinpoint the origin of information, thereby simplifying the process of human verification, a task that is notably challenging with chat models. Recall that after all the problems we faced, the large language model only returned a whole sentence. The currency used in the financial report is sterling. This poses problems downstream as the sentence needs to be interpreted. Note that it will often be formulated in different ways. In contrast, the dedicated extraction model returned the 3-letter currency code. This is standardized and can be directly used by any other program. You have seen that the extraction model is not only delivering the correct value, but also highlights an example from where the information was taken. That is very important for a meaningful cooperation of humans and AI. In summary, you have witnessed 3 major problems of large language models. They need too much resources. They are inconsistent. And finally, they are difficult to integrate.